guys, welcome back to my math YouTube channel. Today I want to show you an example where we are going to evaluate the derivative of a function. So I have already talked about the power rule and some of the other basic rules that we need to evaluate the derivatives of a function. Guys, in this example I have tried to combine few different functions including the constant and then the radical and the inverse functions so that we can just see all of these things in just one example. Guys, let us try to look at this particular example and then see how we can evaluate the derivative. Keep in mind, so far we only know the power rule, which is how to find the derivative of a function which is of the form x to the power n. And then we also know how to find the derivative of a constant, and if we have a combination of constants and some other functions. So guys, here let us look at these terms one by one. There's 5 of these. In the first term it is already in the form x to the power n, and then this is also in the x to the power n. This is just a constant. We know how to find the derivative of a constant, but these two guys are not in the x to the power n form. So guys, the first step is to rewrite these two in x to the power n form, and then once they are in the x to the power n form, we can use the power rule and the combination of other basic rules to write the derivative or to find the derivative. Okay, so let us go ahead and start doing it. So first of all, I'm going to rewrite this function f of x equals to x to the power 4. This is already in the x to the power n form. Guys, we can easily write this inverse function as x to the power n, because if I just bring that x upstairs in the numerator, we already know that here there's an invisible 1 as an exponent. So when I take it upstairs, it's going to be x to the power -1. That is one of the basic properties of exponents. Guys, then what is going to happen here? This is 2. We know the radical x is same as x to the power 1/2, but when we take it upstairs in the numerator, it's going to become x to the power -1/2. So let's keep that in mind. What about the other ones? Well, the other two terms, we're just going to write them as it is because they are already in that form that we can find the derivative for. So it's plus x to the power -1/3 and then minus 13. So to find the derivative, which is f prime, or you can say df over dx, depends on which notation you want to use. So we got to find the derivative of each piece. So guys, in this example, I'm actually going to write all the steps, and then in other examples, I can probably skip, or I will skip some steps and just try to do the derivative right away. So I'm going to do the derivative d over dx of this x to the power 4, and that is also one of the properties that we talked about. And then we have to just take the derivative of each individual piece. That's exactly what we are doing here. 3x to the power -1. Then there's a minus here. We got to keep that minus. Then d over dx of 2x to the power -1/2. Then I have a plus d over dx of x to the power -1/3. And finally, we have to take the derivative of -13 minus d over dx of 13. Okay, I already took that negative out, so it's just the derivative of 13. Okay guys, moving on, f prime of x. We can directly use the power rule. Using the power rule, what happens? The coefficient, the exponent comes in the front, and then you have x to the power 4 minus 1, just using the simple power rule. N times x to the power n minus 1, so 4 minus 1 is just 3. That takes care of the derivative of the first one. Guys, for this one, we already know what to do with the constant. You just take the constant outside, and then you just have to find the derivative of x to the power -1. Using the power rule again, it's going to be -1 just comes outside, and then it's x to the power n minus 1. -1 minus 1 is going to be -2. All right, -2. Then moving on, 2 is just going to take that outside, and then derivative of x to the power -1/2. We know that the power rule works for any values for n, whether it's an integer value, a positive value, or a rational value, or an irrational number. Okay, so here we have a rational number of the form -1/2, so it's still going to work. It's times n, but n in this case is -1/2, and then times x to the power -1/2 minus 1. So -1/2 minus 1, we can simplify that. That would be -3/2, and I hope you can already do that on your own. -3/2, that is the exponent here. And then this one, the next one is going to be, again, it's x to the power n form. I got to bring that -1/3 in the front, -1/3 in the front, and then x to the power -1/3 minus 1. And if I simplify that, it's going to be negative 1/3 minus 1. So it will be negative 4/3. And then finally, guys, the derivative of any constant is, we already know that, that is 0, right? Because when you think about a constant, it's an horizontal line. And then if you think about finding the slope of a tangent to that horizontal line is basically finding the slope of that horizontal line, which is going to be just 0. So we don't even have, okay, we'll write that 0, but it's not going to make any difference. Guys, I think we should still simplify this. So simplifying further, the first term is just going to be 4x cubed. Then this guy, we got to simplify this. It's just 3 times negative 1 is just negative 3. And then guys, x to the power negative 2. Okay, then what happens here? Negative times negative is positive, and 2 crosses out. And I'm left with x to the power negative 3/2. That is this one. And then here I have positive times negative. So positive times negative will end up with a negative 1/3. And then x to the power negative 4/3. We don't have to worry about writing the 0. So guys, here is my final answer. Now, guys, there's one more thing that I want to tell you about this. Now, sometimes if people are in the textbooks or other places, people don't like to have final answers with negative exponents. Then you guys, you already know what you have to do. Then you have to like bring it downstairs. So it will become negative 3 over x squared. Same thing, it will become 1 over x to the power 3/2. And same thing right here as well, because you're bringing these values downstairs in the denominator. So the signs of the numerators or of the exponents are going to change. So guys, this is totally fine. But again, if you find a different answer, then you may have to just bring those values or these exponents downstairs, and then you will end up with positive exponents. So guys, this is example 1. I tried to cover different functions here so that we could just do like everything in just one example. Guys, in my next video, I'm going to show you some application problems still based on the idea that the derivative is the slope of the tangent line. And also the idea that we are using so far, like these basic rules like power rule and some of these other rules that we have talked about. Okay guys, till then, take care. I will see you next time.